Alright, so does anyone remember from last class what a chord is?
Like to the side.
Mm-hmm. So it's just a segment inside the circle. Exactly what you said. And it touches the sides. I don't think arc was our vocab last time. Did you guys know what an arc is? Curved line, yeah. So what I'm going to write is just part of the outside of the circle. So chord's a straight line in the middle. Arc is on the outside, on the rim of the circle. Alright, then the rest of this page is our theorems that are what we use to solve the problems. Do you guys want to read them and figure out what they mean in your own language? Or do you want me to explain them in my language? Our language isn't always the same language. Sometimes the way you phrase things is different than the way the teacher does. Do you want me to go over them? So, congruent corresponding chords theorem just says our basics are if the arcs are the same, the chords are the same. So in the diagram just helps you see. So if the inside chords are the same, the arcs outside of them are going to be the same. And perpendicular chord bisector theorem says if the diameter, so this is dealing with diameter, is perpendicular to a chord, then it bisects it. So if we know one line's the diameter, and we know it's perpendicular, then I can set up these two sides the same. And that would also mean that the arcs would be the same because the arcs follow the chord. Do you guys remember what that word converse means in the next one?
It's a shoe. I remember that one.
It is a shoe. What does it mean in geometry? No one remembers converse?
It was like the first week of geometry.
Not
Wait, what is it?
I don't remember. I remember
Okay.
just doing the first week.
So converse is just like the opposite or switch it around. Okay, so this is just stating it the other way around. Say, if we know that it bisects, then we know this is the diameter. So do you just see the difference between these two? Here it told us this is diameter and perpendicular, therefore we know that these are congruent. Here we know that the chords are congruent, and therefore we know it's the diameter. So converse just means working it backwards. And see, this is why we're letting you guys have a note card for quizzes and tests, just if you forget how to set things up with these, a little note card, just reminding yourself of what these are can really help. Okay, and the next one is just, if we have the same circle or congruent circles, two chords are congruent only if they are equidistant from the center. What does that word mean? Yeah. And so if it doesn't tell us the chords are congruent, but it tells us that they're the same distance from the center, and that always means perpendicular distance because, you know, distance can change depending on the angle. So those are the things we use for this part of notes. So switch over, and this is where we apply them. Alright, so the measure of arc WX. Any ideas of how we would find arc WX?
You gotta use like a theorem.
We would use a theorem. So first of all, do you guys remember, are arcs measured in numbers or degrees usually? Yeah, so arcs are measured in degrees. Doesn't actually equal degrees, but we measure them in degrees. And so what number here of degrees do I have that would help me find an arc measure? 42. So do you remember from last class, if the interior angle is 42, is the arc the same? Yeah, so if that central angle is 42, this is also 42. Are these vertical angles here?
Yes.
So if this is 42, what's WX?
42.
Okay. So that's a review of the theorems from last class. Again, this is why we're letting you bring that note card if you need for help you with quiz. Last class? You'll use that last class. Okay. YZ, this is missing the symbol, but this should be arc YZ.
Are they all
Would also be...
42. Wait.
No, I'm sorry. That's not... I'm wrong. That should be a straight line symbol, because otherwise I'd have the measure of arc. 3.6. How do we know it's 3.6? Yeah, and because they're congruent with the angle measures, we know they're also congruent segments. Okay, what about WZ? 9.2. And arc XY?
If that's 42, it has to be...
Has to be something.
138.
138. How do we get 138?
Subtract it.
Yeah. So you can recognize the half circle and do just 180 minus 42. Or you can recognize the whole circle as 360 and subtract the 42s and divide it in half. But usually if we're finding angles, we'll find the half circle because it's easier. Alright, for numbers 5 and 6, what is our rule here? What's our theorem? Find the value of x, and what do you say? Perpendicular, and we have diameter, so what does that tell us about the two sides? They're congruent. So when we have it set up like this, we just know that they equal each other. So 2x minus 4.1 equals x minus 0.5. And see if you can solve it faster than me. Did anyone get it? Did you get it faster than me? Good for you. Because I have the answer key in front of me, so it makes it easier to solve it. Alright, 3.6, and then if we want to plug it back in, we can do 3.6 minus 0.5, which means this part is 3.1. 3.6 times 2 minus 4.1. Does that also become 3.1? It does. So we know it checks. And you don't have to, if it doesn't ask you to prove it, you don't have to check it every time, but it always helps to make sure you're on the right track. Alright, these ones, do it on your own, see what answer you get for number 6. So do number 6. If you get stuck, ask someone in your group. I mean, sometimes it reviews back to what we did that first day also. But you're right, it tells us if they are equidistant from the center, which they are, we have the 3 here, 3 here, then they equal each other. So then we just set up 5x minus 2 equals 3x plus 2. Can you solve it faster than me? X does equal 2.
They did it a long time ago.
Not even summer yet.
Alright, x equals 2. And next one, how quickly can you solve that one? It comes out to 3. Do they, how'd you set up the next one? Is it the same?
Yes and no. Wait. Can I answer the question you just asked, or is that like a rhetorical question?
Was there the same distance, so they set them equal to each other?
Yeah, so what were you going to say, Claire?
I was just going to say, well, if the outsides are equal, then the insides are equal. So if the outsides are already 20, then the insides have to be the same.
Hey, it's 3.
Yeah. And yes, when you solve it out, it does come out to x equals 3.
Yeah. How'd you get that? You didn't go to the baseball game.
No, I didn't. I was really sick.
Okay. Are we done with these problems?
Yes.
No.
I feel like
Why not?
No, why not? Find the radius of the circle. Okay, so those were really easy. Solve for the missing part. We have another step. So what is the radius of the circle? Do you remember from last time?
The dot to the,
Yeah, so it's the dot to the edge. What could I use when I know this part and I know this part to Pythagorean theorem? So this one, if I know, well, I first have to plug in the x. So 3 times 2 plus 2 equals what? 8. So if the whole thing is 8, what is this part of it? 4. Is that one of our Pythagorean triples?
Yeah.
Yeah. So radius equals 5.
wait, how you do that?
So
Okay.
3 and 4 is a triple. And we should have this memorized, right?
I mean, at least the basic ones like 3, 4, 5, or like 6, 8, 10, those just show up a lot. If you don't, you can plug it in and do all the math. Okay, so review, because a lot of people, I think, I did that kind of fast. So when it tells me find the radius, I recognize radius is from the center to the edge. Were you all with me in that step?
Yeah.
Okay, and then to do that, I can do Pythagorean theorem because I know this is a right triangle.
Oh, you know that equals 3, that's 4, and
Mhm.
that's half, so just, okay.
And then I plug it in to figure out what this portion is. So then let's do the same thing here.
Okay,
If the whole thing's 20, what's this part?
10,
When I plug in 3, what's this part?
7,
7. Is that a triple?
no.
Sadly, no.
So just set it up.
So yeah, we have to set it up.
Okay, wait. When you get a call today?
I'll get it when I get home.
It's like,
Yeah.
I can call the school.
you
Because cell phones are not a necessity of life.
Well, we don't have
We don't live in a.
Yeah.
we don't have
They can, anyone, like, if your parents have to get a hold of you, they can always call the office and get the office to get a hold of you here.
Yeah, but then the office will take like 10 minutes more. Yeah. Too late.
Yeah, what if they're already kidnapped?
There's always like.
Well, these next 3 are to cover some important theorems that you use to solve problems. And your job right now is in your groups. We're going to take about 10 minutes to just follow through step by step for these 3 circles. We aren't doing circle 4. And so draw the lines and stuff they do, measure them, and figure out what word needs to go in the fill in the blanks here. Okay? So, yes, you'll need rulers. Okay. So, desk number 31, what did you get for the circle conjecture number 1?
60.
So you're right, they both came out to 60 when we drew it. And then if we're looking for a word that would be true of anything, what?
You said at the beginning of class.
Yeah, the same, or yeah, because if we said is the 60 as the measure of the arc it intercepts, that wouldn't quite work. I know. Okay, because these can, you guys, these are take the place of theorems instead of giving you the wordy theorems. This time we're just coming up with the conjectures, but these are the ones that are always true. All right, desk 10 in the back. What do you get for conjecture number 2? Okay, so they were both 30 when you did them. They came out to roughly this, right? And so someone, if we are, yeah, the word we'd look for is half. So that's a really important thing to remember. If we're coming from the central angle, it's the same. If we're coming from an inscribed angle, which means it goes all the way, touches the edge, it's half.
That's the wrong triangle.
That's the wrong one?
That's for 3.
Oh.
You get A, D.
Oh, yours, I see.
Yeah.
They're both 30 though, right?
Yeah.
Okay, so then desk 20, what did you get for conjecture 3?
Oh, sorry. Like for the answer right there.
Yeah.
It said congruent.
Perfect. So another really important, and these are all the things we use to do. Hey, central angles are the same, inscribed angles are half. If they intersect the same arc, they're congruent. All right, for the second circle, conjecture 4, I got desk 27 this time.
Oh.
What word did you get for that? So, angles inscribed in semicircle are congruent angles. What do you guys think? Did someone get a different word there? What would you guys get? Right angles. Or right angles or 90 degree. So the key word there, because again, right angle is something we use a lot, is semicircle. So if one side of the triangle is the diameter, then you know you have a right triangle. That angle's 90, right? Or if you did it, your second triangle like this, it's 90. All right, and flip to the next page. Desk 12. Louise, right? Can you ask someone around you then to No one in the group did? Okay, call into another group. You have to pick someone. Alright, who wants to volunteer and rescue that group that didn't get to it?
What are you doing?
So, circle conjecture 5.
You want us to answer the question?
Yeah, the question. What'd you get? Supplementary, yeah. Okay, what does supplementary mean?
180.
Yeah, they add to 180.
Supplementary.
Alright, you guys, focus in back up here. So, this is what you should have... boys. This is what you should have gotten when you drew this third one. So several people told me you didn't get to it. So...
I got 100 for C, I got 70 for B, I got 116 for A, and I got 64 for B.
I was so confused about it.
It should have come out to the same angles. Did you guys get different angles for this? Is my key wrong or?
No, but like I did have enough. Like I was like 5 off on C.
Oh, okay. So just in the count.
And then I was 1 off on.
Alright, so when you have that, flip to page 9. We're going to apply these real quickly, and then you'll have the rest of the class for your homework.
We have to go to page 9.
Yeah, go to page 9. Why is this not letting me move it? There we go. Okay, so we're just going to apply those to find the measures here. What is the measure of angle 1?
90.
90. How do we know that?
Because of angle.
Yeah, it's that triangle with a diameter. What is the measure of angle C?
Oh, I got this.
What could we do knowing that this angle's 90? Yeah.
Because if that's 90 and then it's 20 at the bottom.
Mm-hmm. So,
Wait, what did you say?
180 minus 90 minus
62.
28.
yeah, so we have the whole triangle. We know it's 180 minus the 90 minus the 28 that they already gave us, which gives us 62. Okay, so just back to simple triangles because we recognize that it's 90-degree angle. Okay, how about a segment BC? What could I do to solve for that? Pythagorean theorem. So 3.9 squared plus 7.3 squared.
8.28.
Mm-hmm. And so when we do the math, it comes out to 8.28. We're going to round it to 8.3 because the others are 1 decimal. Alright, measure of arc AC.
That's supposed to be an arc.
Yeah. Sorry, the arcs didn't print out well. So what do we use to find measure of arc AC?
28.
It is degrees. Is it 28?
No.
No, what is it?
Times by 2. 28 times 2?
28 times 2. What's that come out to?
It's half.
Because it's a then, yeah, 56. So, yeah, remember if it's inscribed, if the vertex is on the other side of the circle, then it's half. So we have to do times 2. If the vertex is in the center, then it's the same. Alright, and then measure of arc AB. Close.
92.
So I heard 90, I heard 92, I heard 7.3. So arc AB. So first of all, arc AB, are we looking for degrees or like
Degrees.
degrees? And so that means we're looking at the angles.
So it's
So what angle is, so arc AB, what angle is that going off of?
wait, no. 275.
I'm sorry, arc AB would be the other way.
We have to go now. It was
Oh, yeah, okay. You guys need to go. Alright.
Well, is it a semi? No, sorry.
Alright,
93.
Alright, you guys, so first of all, arc AB, I started labeling wrong. So arc AB we know is this short distance here, which means I'm going to go off of angle C here, right? It is 124.
How
See,
you do
that's
124?
that. Because the 62 is the measurement of C, and then
You
you
really
C
got me
across.
thinking.
It's turn 2.
Okay.
I don't know.
Okay,
Where?
so,
What?
I did.
so look, yeah. Okay, so yeah, 2 ways you can do it. We already know that this section is 56, so you can do the 180 minus 56. Or you can recognize, okay, so do I have an inscribed angle to match it? Yes, the angle C is what intersects the arc AB. And we already know angle C is 62, so therefore I do 62 times 2. Either way, they become 124. You guys see it?
No, wait. What? Because it's half.
So take a second and look and see. There's 2 ways we can get it. See if you can figure out.
16 is the angle of C.
Mm-hmm.
I'm trying to find that out. Yeah, because since we don't have it on the bottom, if you draw the other triangle, the other side of the triangle,
Mm-hmm.
to make a rectangle, it's
You can always do it that way too. Alright, we ready to move on? Yes? No?
Yeah.
Okay, so focus back up here. We just have 2 more. Here it says name 2 pairs of congruent angles. So first of all, we name angles with our angle symbol and the vertex, right? So if I just say angle A, is that enough to let you know which angle there is? Well, AB would be a segment.
Angle A.
So if I just say angle A, is that enough to let you know there's no mistaking that this is angle A, right?
Yeah.
Okay, what's congruent to angle A?
Angle C.
Okay, so we say D and C. We're pretty split here. So this one, there's just some. So is this the inscribed quadrilateral? Yeah, it's D. How do we know it's D? So what I'm looking at is angle A intercepts this arc, right? And then I say, what's the other one that intersects this arc? Well, that's angle D. Do you see it? So it would be angle A and angle D. This isn't the inscribed quadrilateral because the lines crisscross, so we're just saying, hey, we're looking at which arc goes along with which angle.
That's too much.
Alright, how about if I start with angle B? Which one matches that one? Angle C, because again, they both are intersecting this arc here. So this is something I found some people see this easily.
How they intersect?
Sorry, so when we're talking about arcs, we say, hey, where does that angle come and touch the circle? Right here and right here. And D touches the circle, angle D touches the circle at the same two places. And therefore, those are the ones that match that arc. They're inscribed angles for that arc.
Oh, so
They're not touching
it's just the placement of where
Yeah.
it touches.
Yeah, it's where, so this is angle A, this line comes and touches here.
Yeah.
And D, this line comes and touches the same spot. Here, this line comes and touches here. This side touches on this part. Okay, so we'll keep working with it. I'm going to finish the notes so people can get on to their assignment, and then if you need help, ask me. Okay, find the value of each variable. What's our rule here?
I don't know.
Oh, supplementary.
Yeah, opposite angle supplementary. What does supplementary mean again?
Equals 180.
Add up to 180. So if D is 100, what is N?
80.
80. And then what does M equal? Nice and easy, right? Do you see why we tell you you can use a note card in this test, though? There's just lots of little different things that you might need
Okay, now go
to
back
write
to
yourself
26.
Okay, so